subtracting rational expressions is the fancy word, but adding and subtracting fractions kind of will work. So let's see. I'm not sure why this is showing up here. That's not a good start to the video. Go away. Section 8.8. Let's just close that out altogether. Maybe that'll do it. Yeah, that works. So problem number 70 asks us to add a couple fractions together. 2 over 5a plus 3 over 2a. Now when we're adding or subtracting fractions, the real pain about it is that you need something, what? Common. You need something common. You need a common denominator. So we got to figure out what that is first. Now the lowest common denominator in this case is going to be the lowest common denominator between the 5 and the 2, which is a 10, but it should also have that factor of an a. So 10a is your LCD. Now we're going to want to write this as something over 10a, and this is something over 10a. To get there, we're going to need to be a little bit clever. We don't have an equation here. We can't multiply both sides by 10a and cancel out the common denominators, or cancel out the denominators. But what we can do is we can multiply by 1. Now, what do I have here, or what do I need to multiply this by to get to here? 5. Do I need an a? Just a 5. So I'll multiply by 5 over 5. So that's effectively 1. But instead of canceling these things, I'll just multiply. That gives me 15 over 10a. How about over here? What should I multiply this one by? 2. Excellent. 2 over 2. That gives me 4 over 10a. And now that I have common denominators, I can just add these together, right? So 4 plus 15 over 10a, or preferably 19 over 10a. You don't have to show this step, but sometimes it might be to your advantage to kind of carefully write it out. All right, so a friendly one to start with. Yes, looking good there. I wonder how sensitive this mic is, if they can hear the passing train or something like that. It's my ride. Yeah, it's my ride. All right, good deal. I'm afraid that's done. Yes. Yeah. And there's no common factor. There's no simplifying this. Sometimes you can, and in which case I do want it in lowest terms, but there's nothing. Boy, it's a really obnoxious train. They're mad at me because I'm not out there. All right. Yeah, if it does simplify a little bit more, then please do that. Okay, let's try another one. Problem number 74. So kind of sticking with the same theme there of monomial terms in the denominator. 5xy cubed minus 2 over 15x squared y. Okay, so as far as the LCD is concerned, let's take a look at it in a couple parts. Between the 5 and the 15, what's the LCD? 15. Okay. How many x's do I need as part of my LCD? That would be what's common, but I need 2 of them as part of my lowest common denominator. And then I'll need 3 y's. All right, so let's do this. 1 over 5xy cubed minus 2 over 15x squared y. And now let's figure out, well, what do I need to multiply this by to get this? 3 and an x. Yeah, and that's it. 3 and an x. And I'll do the same thing here. I got to look and say, all right, well, what do I need to multiply by to get this piece over here? Yeah, just a y squared, right? I've got the 15. I've got the x squared. I need 2 more y's. So thank you, a y squared. Hey, that's cool. In the denominator, I've got a 15x squared y cubed And then over here I get a 15x squared y cubed, which is what I need. In the numerator it's 3x and 2y squared. You don't have to show as many steps as I'm showing. My goal here is that I don't lose you. So if you want to kind of make this a little bit faster, that's fine. Your final answer should look like this. And that's it. Please don't do any cancellation. Remember, these terms are kind of married together. You can't really cancel into that marriage. How are we looking on problem 74 there? All right, looking good? Any thoughts on this one? Anything else you'd like me to discuss? All right, no. Can we be done? All right. Can I go home? My brain is full. Problem 78. 2 over a plus 4 minus 6 over a plus 3. Now the problem with this one for a lot of folks is that they try and think of the common denominator as just between the 4 and the 3 and say, oh, well, 12 is my common denominator. But you have to look at it. You have to look at it as these terms are whole terms. It's not just an LCD between the two numbers. So the LCD in this case is going to be a plus 4 times a plus 3. It's going to be the product of both of those. That's going to be our lowest common denominator. But the game here is still the same as it was with the last one. We're going to go through and introduce, by way of multiplication, the stuff that's missing. So, salsabila. What am I missing from this denominator that I have over here? What term? Yeah, what's missing from this that I have over here in my LCD? A plus 3, thank you. So, a plus 3 and a plus 3. This is effectively multiplying by 1, so it's not changing the fraction, but it's just giving me my common denominator. And let's do this. All right, a plus 3 times a plus 4, and then the numerator I'm going to distribute. So it's going to be 2a plus 6 minus. Well, let's see what happens here. What am I missing here? A plus 4. A plus 4. And that's going to give me 6a plus 24 over a plus 3 times a plus 4. So far, so good on that one? Okay. We've got common denominators, right? So I can subtract the numerators. 2a plus 6. And don't copy this down just yet. If you write just minus 6a plus 24, I think you're headed for a mistake. Can you see what's wrong with what I've got here? No. What's wrong is that negative has to distribute itself to both terms. So when you're subtracting, it takes a little bit of extra care. It's going to be 2a plus 6 minus 6a minus 24. So both of those have to be subtracted. You have to distribute that negative to both terms. So it's a subtle but annoying thing you got to work with. I'm not done yet. I got like terms that I can combine. Jacob, can you help me out with that? What do I get when I simplify that? Good. So negative 4a minus Well done. So a plus 3, a plus 4. Now, if there's some extra cancellation, I would want you to do it. There really isn't any in this case. You could, if you're really motivated, factor out a negative 2, which leaves behind 2a plus 9, a plus 3, a plus 4. But in my eyes, you know what, you're not going to get any more cancellation, so this is okay. If there was some more cancellation, I'd want you to do it. Kira? Mm-hmm. Yes. But you would have had a plus 24, which would have given you a 30 here. So if you didn't have the parentheses there, you didn't distribute that correctly, that'd be plus 24, you would end up with 30. And you know, this is as frustrating for you as it is for me. Because a lot of times I'll give you problems, and I'll tell you this right now. There's probably going to be a problem where there's going to be one like this, and you'll get some extra cancellation, but if you miss that negative sign, then when you factor it, it's like, oh, well, there's no cancellation, I'm done. But, yeah, it's a costly mistake. You know, there's not much I can do about it other than tell you ahead of time to be careful with those negatives. Yeah, sorry about that one. Don't shoot the messenger. Thanks for the question, though. Anything else on problem 78? Okay. Let's try problem number 82. X over x squared plus 2x plus 1 plus x over x squared minus 1. Ugh. Now, before you start getting all like, oh my God, this is awful, let's take a look at the denominators and see if we can't factor them before we decide what the LCD is. Because this one's not going to be as bad as it looks initially. But let's see if we can't factor these things. So, how about this first one? How does that factor? Plus 1, x plus 1, and x plus 1, right? Now, you really need to write it as x plus 1, what? Squared. How about the second one? How does that one factor? Yeah, a minus and a plus. So x minus and x plus, 1 and 1. So this is a good example because our LCD is going to be a little bit more interesting than some of the previous ones. LCD. First of all, let's list all the different factors. I'm going to have an x minus 1 and an x plus 1. But if you think back to problem 74, when we came up with the LCD, it wasn't just x, it was x squared. It wasn't just y, it was y cubed. In other words, what were we doing? We were picking up the highest power of each of these factors, right? So what's the highest power of an x minus 1 term anywhere? That's a 1. What's the highest power of an x plus 1 term? 2. So your x plus 1 has to be squared. You have to have 2 of them to be part of your LCD. And this is just like we did in problem number 74, except this time we've got binomials. That's okay. We're looking all right. X over x plus 1 squared plus x over x minus 1 times x plus 1. So let's look at each of these and figure out, well, what am I missing so that this would be the LCD? All right, so I'm missing x minus 1 from both the numerator and denominator. So I'll multiply by x minus 1 over x minus 1. How about over here? What am I missing with this one? Well, I need an x plus 1 squared. I've got one x plus 1 term, So how many more x plus 1 terms do I need? 1. So it'll just be x plus 1 and x plus 1. Okay. So can we get lazy for a second? All right, this is good. This is my LCD. So I'm just going to write LCD there. At the end of my problem, I'm going to go back and write what it is, but I just feel like getting lazy here. Now, in the numerator, let's distribute that x. That's going to be x squared minus x. All right? Can we get lazy again in the denominator? I think so. X plus 1 times x plus 1 is x plus 1 squared. Times x minus 1, hey, guess what? That's our LCD. But like the previous one, let's distribute this x to both terms. X squared plus x. Nice. These both have the LCD. So I've got x squared minus x plus x squared plus x over the LCD. Can anyone simplify that one? Alexa, you see any simplification there? Okay, so these cancel, right? But if I have one of these plus another one of these, how many do I have? 2 of them. 2x. That wouldn't be the force, it would be squared. Just be 2x squared. So it's 2x squared. Because, I mean, effectively, what's happening here is I've got one of them here and one of them here. 1 plus 1, that's what gives me the 2. You would add exponents if you were doing some multiplication. And finally, over the LCD, my LCD was x minus 1 times x plus 1 squared. Whew. All right. Don't worry. I don't put any more than 8 or 10 of them on an exam. Yeah. All right. A little bit more challenging problem, but kind of the same thing that we've done with the previous 4 or 5 examples. But if there's something that you're just like, oh, I didn't get this, now's a good time to get some help. So, what you got? Lucas, so it looks like you got a question itching. You're okay? Okay. All right. No one else? All right. So, everyone's going to get an A on this on the test, right? All right. Good deal. That's what I want to hear. Let's switch it up. Just 3 more problems for the end of this section. We're going to deal with rational equations. Now, these were just rational expressions. We were adding them together, subtracting them to simplify them. But if you have an equation, then life gets a little bit more fun. You can do what you kind of wanted to do anyways, which is multiply. Just multiply and get rid of them. So, problem number 90. This is no different than the other problems we had with fractions earlier in this chapter. And I said, if you have something that deals with fractions, the first thing to do is get rid of them. Get rid of the fractions. So to get rid of the fractions, we're going to have to multiply everything through by the LCD. Take a moment and see if you can't figure out what the LCD is for this particular problem. All right, so check your answer with your neighbor. See if you agree what the LCD is. What is that LCD for this particular problem? All right, this is the part where you make me look good, right? Remember? All right. 2x? All right. I was thinking of checking in with each other, but that's okay. So 2x is our LCD. 2x, 2x, and 2x. Everything's getting multiplied by 2x. If it helps you, you can think of it as 2x over 1. But what you want to do is you want to do the cancellation here. You want to get rid of all those terms from the denominator. So the x and the x cancel. The 2 and the 2 cancel. I didn't mean to cancel the x. And over here, all of that cancels. So let's see what's left. 4 plus, and I cancel out the 2 there, so yeah, it'd be just x equals, wow. Hey, that wasn't too bad, right? Can someone solve for x for me? What does x equal? 3.
That was easy.
Yes, that wasn't too bad. Certainly a lot friendlier than, say, our previous problem, number 82 was. Are we okay with that one? Yeah. Okay. Yeah. You're like, whew, hey, that wasn't so bad. Let's try problem number 92. 7 over 5x minus 1/2 equals 5 over 6x plus 1 over 3. All right, so we're going to have to do a little bit more thinking for the LCD. Now, one of the things that's going to be part of our LCD is a number. Think about a number that all of these go into. 30. All of them go into 30. What else has to be part of my LCD? X. Good. Ah, there's the making me look good part. Thank you. So 30x. Now let's multiply everything through by 30x and do some simplification and see if we can't finish solving. Alright, so let's see. So 30x, 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 30x. Does it help you if I put it 30x over 1? Does that help you keep it straight and do that cancellation? A little bit? Yes? No? Alright. So let's put that there. There's a lot of cancellation. So if you watched my videos before, you realize that the software that we have here doesn't exactly have a pause button, so this is a manual pause. So if you're watching this, you can pause it or fast forward to the answer. But I'm going to give you a chance to work on it. So see if you can't finish this one up. First one with the right answer gets to stay an extra 10 minutes. So the nice thing here is that we can get a lot of cancellation and then move on. 5 goes into 5 once and into 30 6 times. The x's cancel out all together, so that's a good thing. 6 times 7 is 42, so let's do a 42 here. Minus, not much cancellation here. 2 goes into 2 once and into 30 15 times. We didn't cancel the x, so it's minus 15x equals. And let's see what happens over here. The x's cancel. Those disappear. 6 goes into 6 once and into 30 5 times. 5 times 5 is 25 plus 3 cancels into 30 10 times, so 10x. Now, let's put the variables on the side with the larger coefficient, so I'll add 15x to both sides. That'll put my variable on the right-hand side. At the same time, let me also finish this one up a little bit quicker. I got my variable over here. Let's put the constants over here, so I'll subtract 25. I get 17 equals 25x. Divide both sides by 25. And boom. Whew. All right. How many people got that one right? All right. So, for my viewing audience, everyone got it right. This is a good thing. For homework, try 33 through 53, 59 through 83, 89 through 93, 101, and 105. Those are just the odds. That's section 8.8. Okay, good luck with that one.